If I'm going to land up working out the mass of water obtained from a certain mass of nitric acid, the first thing I'm going to do is write my information that I already have. So I have a mass, 126 grams of nitric acid. The question mark is, what is the mass of water? I know the molar mass of nitric acid, or it's easy enough to calculate. It's 1 plus 14 plus 3 times 16, so it turns out to be 63. And with that, I'm able to use the equation that number of moles is equal to mass over molar mass. And that information is given on the information sheet. So number of moles is equal to mass over molar mass, which is equal to 126 divided by 63. And that turns out to be 2 moles. Now I need to work out a relationship between the invisible 1 over there and the 2 over here. So I am linking nitric acid with water. In doing that, I've got a 1:2 ratio, but I don't have 1 mole of nitric acid. I have 2 moles of nitric acid. What did I do to the number 1 to make it into the number 2? I multiplied it by 2, so I take 2 multiplied by 2 and get 4. That means I have got 4 moles of water. I've also can work out the molar mass of water very easily. 1 plus 1 plus 16 is going to give me 18 grams per mole. Going back up to the triangle, I now would like to find out the mass. So it's going to be number of moles times by molar mass. Mass equals number of moles multiplied by molar mass. And I go 4 times 18 and land up with an answer of 72 grams. They then say what volume of oxygen gas is given off at STP with exactly the same mass of nitric acid. So now I'm interested in a volume of oxygen gas. The volume of oxygen gas, I'm going to draw up a relationship now between the nitric acid that I know and the oxygen gas. There's an invisible 1 over there. There's also an invisible 1 over there. So it's actually quite easy. It's a 1-to-1 ratio. I don't have 1 mole. I've got 2 moles of nitric acid in 126 grams. So it's 2:2. And that means that I have 2 moles of oxygen gas. They're not asking me for mass. They're asking me for volume. So it is a gas. It is at STP. So I can use molar volume, which is 22,4 moles per cubic decimeter, and I am going to get volume is equal to number of moles times molar volume. And if we're looking for a triangle on that, it's number of moles, volume, molar volume. And if I then take the volume out, I land up with number of moles times by molar volume. I then go 2 moles times by 22,4, and I land up with an answer of 44,8 decimeters cubed. Sodium reacts violently with water to form a basic solution, and they give me the balanced equation. Calculate the mass of water needed to react with sufficient sodium. So we're not worried about how much sodium we have, there's enough of it, in order to produce 260 grams of sodium hydroxide according to the following equation. So I'm going to say the mass of sodium hydroxide that I need is 260 grams. The question mark is what is the mass of water required. The molar mass of water we actually just saw was 18 grams per mole, and the molar mass of sodium hydroxide is 23 plus 16 plus 1, so it becomes 40 grams per mole. I've got more information about the sodium hydroxide than I do about the water. Number of moles is mass over molar mass. That's on your information sheet, which is going to be 260 divided by 40, and that comes out to be 6.5 moles. What is the relationship between the number in front of sodium hydroxide and in front of water. I make sure I do a ratio between the two, and it is 2 is to 2, which is the same as 1 is to 1, and if it's 6,5 in the sodium hydroxide, it will be 6,5 in the water. So my number of moles of water is 6,5 moles. If I'm now looking for a mass of water, mass is equal to number of moles times molar mass. My number of moles is 6,5, my molar mass is 18, and I land up with an answer of 117 grams of water.